Hello and welcome to our lesson on the TI-84 Plus CE student course. In this video we are focusing on data and statistics, and in particular statistical plots and bivariate data. And some of the key things we are going to look at are how to generate a scatter plot, using the zoom and zoom stat functionality to see the graph clearer, storing a regression equation, sending large data sets from other sources to your calculator, and residual plots. So you should already know how to type the data into your calculators, and we can see here that we have 7 data sets or points, and at the moment there will be no graph because we haven't set it up to graph anything. That's done in stat plot, so that's in blue, and we're going to turn the first one on, make sure it's on, scatter plot, and our data is in list 1 and list 2. That's the icon that I like to use, and if we now go to graph we can see that those points are on there. We're lucky that the values that we chose are within the window that we have already set, but lots of times we won't see anything. When we go to graph there'll be nothing there because the values are off the sort of the visual window of the screen. So a very simple way to do that is to go into zoom and go zoom stat number 9, and that will adjust the window for you, and that will give you a nice window for you to look at. I also like you to think about doing it manually by looking at the data set itself and saying, well, I need to go between 0 and 6 and say between, I don't know, 1 and 5, so that you would then change this to 0 to 6, going up by 1, and between 1 and 5, going up by 1. And I quite like doing it manually, and then we could adjust it if we needed to from there. To produce a regression equation, you should know that you go across to calc, and there's all our regression equations from 4 down to C for sine regression. But we're going to choose linear to start with, and we know that if we choose list 1, list 2, come down to calculate it, it will give us a linear equation, and gives us the R and R squared. That's because in mode that we've got stat diagnostics on, but it doesn't actually add the line of best fit. And that's because when we did the calculation for linreg, we actually didn't store the regression equation. And the quickest way to do that is to go into alpha F4 and get the variables, and we're going to store that one as y1. And we can see now that everything's the same, but here's the straight line because it stored it into y1. And that then allows us to compare other ones. If I go to an exponential, which I know is 0, list 1, list 2, and this time I'm going to store the regression equation as y2, we'll see that the r squared is slightly different. We'll see now that it dumps it into y2, and we can get a second graph going through those points as well. And we can keep doing that if we needed to. Now sometimes you want more than the data set that you would get in a test or an exam or a question from a textbook, and you may want to get some real data. So I was looking at some data to do with rainfall and temperature in Darwin back in 2021 in the wet season, and you would just copy that data across into an Excel document. So we can see you've got the temperature here and the rainfall for January 2021, all 31 pieces of data. And it's very important that you save this as a CSV file. To do this, rather than just clicking save when you do a normal Excel, you come down to type and you click CSV. There it is in the middle, and that will then allow you to then save it as a CSV file. Now to put that CSV file onto my calculator, and you could do the same for the software as well, we connect our calculator to the TI Connect CE software, which is free and easy to download from the TI Australia website. You can see that I've already connected a calculator here, and if we go into what the calculator actually holds, we can see that there's not very much in list 1 and list 2. There's only 2 bytes of data, which is basically nothing. So we simply just get that CSV file and drag and drop it across. We know there's 2 columns, which is the temperature and the rainfall. So we send both of that across. It's going to put it into list 1 and list 2. That's perfect. Sends it to the calculator. We can now see that the memory's increased dramatically for list 1 and list 2. And if I go to my calculator and then do a screenshot for you just to show you, we can see that there is all that data from that Excel spreadsheet, and then we could work the same system as we did before. And just showing you that I can actually put it onto the teacher software as well, which is what I'm using for this video. I can simply again drag and drop that CSV file across. We again go 2 columns. This time now I've got data in list 1 and list 2, so I'm going to change that to list 3 and list 4. And we can now see that on my teacher software that same information is on the calculator. A really nice and easy way to get real life data, and don't forget we can share it between calculators using the links functionality and the mini USB cable that you're given in your TI-84 case. So I'm going to finish with a residual plot, and we can remember that these are the 2 graphs that we did, or the 2 regression equations we did earlier from those 7 pieces of data. I'm going to focus on the linear one because that's going to show the regression best, because we know the exponential is a good fit. So that, and this only works to find the residual once you've done a regression equation already. And we're going to go back into stat plot. We're going to go to number 2. This time we'll go to a different stat plot, turn that one on. The x values are still the same, that's list 1, but list 2 is going to be the residuals of those. So to get that, we go into list, which is just above stat, and there it is, number 7. I'm just going to change the color because I can. Just have a different color for that one there. And then if I press graph, we should see the residuals. And why aren't they there? Well, that's because they're about the x-axis, and they're how much these points vary from the line of best fit. So to do that, I just would have to change the window. I could either go into the window and change the x-axis myself, or be lazy and use zoom stat. And we can see now that there is this pattern happening. So a linear was not a good match for this data set for these points. You can also see those residual values in the list page by coming across and adding your own. If we go up to the very top here and come across our own one, we can add our own residual values in here. So if we go back to list as before, and there's our resid, we can get those values to come up in here. And those are the residual values from these green points. And as you go to trace and show you, those same values here are the same values that are now in my residuals here. So if I wanted to compare those to list 1, I could come over to here and copy list 1 across. I can have them next to each other. I can see how they compare. So hopefully, thanks for watching, and hopefully you found this useful.